Greetings, my people. It's your science teacher, Mr. Austin. I welcome you to my channel today. We will be looking at the concept of catenation in this video. Catenation is a concept we always come across in organic chemistry. One would ask, what is this catenation? This catenation is actually a linkage into chains of atoms of the same element, forming a strong and stable bond. If you look at the diagram we have in the slide, you will see how carbon atom links to itself, forming a 5 carbon atom chain, which is pentane. You can see that the chain, the carbons, are attached together by a single bond to each other, forming a compound which by naming we call it pentane. This is an example of catenation. The linkage between an atom, in this case carbon, to itself is catenation. This catenation is predominantly possessed by carbon, but that is not to say that carbon is the only atom that possesses this catenation. There are many other elements such as sulfur, silicon, germanium, etc., that possesses this property, though they possess it to a certain extent, not to compare to that of carbon. Now, the catenated compound, that is the catenated carbon to carbon compound, can come as a straight chain. It can come as a branched chain, or it can come as a closed chain. An example of a straight chain is in the case of the structure we have earlier, which is the pentane, 5 carbon. Then if you are talking about the branched chain, we can have structure like 2-methylbutane. Unfortunately, the structure is not in this video. And then in the closed chain, we can call it closed chain or cyclic. We will have benzene. It's an example of a closed chain or a cyclic compound. The bonds bonding the catenated carbons could also be a single bond, a double bond, or a triple bond. As you can see in the diagram in this video, the first one is a single bond, bonding carbon to carbon. The second diagram is a double bond, bonding 2 bonds, bonding carbon to the other carbon. And the third one is a three bonds, bonding carbon to each carbon. All these are still catenation. You have to note that carbon is the only compound that can catenate with double or triple bond. This property is exclusively that of carbons. Other elements that possess this ability do not catenate with more than single bonds. The ability of a carbon to catenate more than the other elements is attributed to some properties which we are going to look at in this video. One of the properties is the small atomic size of carbon, which enables it to easily form bonds and fit comfortably in a large molecule. This actually is a property that carbon possesses that gives it the power or the ability to catenate to a very great extent. The small size of carbon. That means the small size, it can fit comfortably in any molecule, no matter how large it is. Then second reason is the tetravalent nature of carbon. Out of the 6 electrons contained in that carbon, in carbon as a whole, we have 4 available for bonding. That is, 4 are at the outermost shell. These 4 are available to bond at any time. Carbon can share the 4 electrons to 4 different atoms and can also share with itself to form a compound. If you look at the diagram we have in the video, you will see that the inner shell has been occupied by 2 electrons, then the outer shell we have 4 electrons occupied at the outermost shell, which makes the outermost shell, the 4 electrons, available for bonding, because the outermost shell is not yet filled. So the 4 electrons, in order for us to fill the outermost shell, the 4 electrons have to be filled. Now the 4 electrons have to bond with other electrons to be able to occupy the space that are supposed to occupy in that shell. Now, because of that reason, we have carbon as we have 4 elements at the outermost shell of carbon awaiting bonding. Now, when carbon shares electrons with another carbon, the additional carbon will always have 3 electrons left to share. The 3 electrons could still be shared with another carbon, forming a long chain in that sequence. Let's look at the first diagram we have here. We can see the carbon we have showing the 4 valence electrons. That is to say that this carbon has 4 valence electrons, which means they can bond with 4 different atoms or with 4 different carbon atoms. So when carbon shares electrons, for instance, in this case, the first one we have here showing 4 electrons, when it shares one of these electrons, the additional carbon will always have 3 electrons left to share. Look at the diagram below. You will see that carbon 1 has 3 electrons left to be shared. Carbon 2, because it is at the center, has shared 2 electrons, remaining 2 to be shared. Then carbon 3 has 3 electrons to be shared as well. Now, in this pattern, when we have carbon sharing electrons to itself in such pattern, then we are liable to have a very long chain carbon compounds. And this ability is what we termed catenation. The ability of a carbon compound in this video, because this video is specifically for carbon, catenation in carbon. Like I told you earlier, the catenation could come with carbon elements or with other elements. Then in the case of carbon, we said that carbon is the one that predominantly possesses these properties. We've given you the reasons. So looking at the diagram below, when we have bonding in that sequence, we are liable to have a very long chain. This chain could be straight, it could be branched, it could be cyclic, depending on the condition. Then the bonds could be double or triple, as the case may be. And that is we said earlier, the double or triple bond is a property that is predominantly possessed by carbon. So that is what actually catenation is all about. In this small video, I believe that you've understood properly the concept of catenation, what it means, and why carbon is predominantly possess this property of catenation. So, my dear people, this is where we are calling today for this video. For any comments, contributions, etc., you can drop it at the comment section. Thank you for watching. Bye for now.